politician is interested in the proportion of voters in his district who think he's doing a good job. So we're supposed to match these terms. So right there, before I even look at the options, the politician is trying to find out how many people in his district think he's doing a good job. So the variable should be the choice yes or no, right? Because the data we're keeping track of is whether a person says, yes, you're doing a good job, or no, you're not doing a good job. So it's not this one. This is one outcome of the variable. This is one particular outcome. Remember, the variable itself is the yes or no answer. It's not the yes answer, which is what this option is. Same thing here. This is talking about the proportion of voters, all voters in the politician's district. I think it's this one up here. I'm just making sure. This would be the population. Yeah, this is the variable. I mean, these are really actually the two outcomes of the variable. That's why I hesitated to choose it. But the variable is the yes or no answer. Now the sample, that represents the numbers that we gathered, the actual numbers. So it's not all the voters in the district. It's a random selection of the voters. It's a smaller portion of all the voters, because this right here, all the voters in the district, is the population. And we never have population data in practice. We always have to get a random selection of people to ask. So the random selection is the sample. The population, that's the thing in a dream world that we'd want to have, okay? The statistic, a statistic is like a number that we calculate to try to estimate that population parameter. Let's see. So he's trying to estimate the proportion of voters who think he's doing a good job. So that's the statistic he's really interested in gathering. That's that one number he's looking at calculating the answer for. What haven't we used? We've used these. So on the last one, the data. Yeah, so here's a good distinction between statistic and the parameter. This one up here is the parameter, because the parameter is the number that's true for the entire population. The parameter is also a number we never really have our hands on. A parameter represents the proportion of all the voters in the district, like this is saying. Our statistic was this one because it said it's a sample. Okay, so statistics, let me write that out. Statistics come from samples. Parameters come from populations. Otherwise, they're the same number. And so I think we crossed everything out. The data, and that's kind of a weird form. X is the voter in the district who think the politician is doing a good job. That's part of the data, and that's not all the data, but I guess that's what they want here for this last one. Okay. No, it looks a little jumbled up, but hopefully that gives you the idea. Look, the variable is the numbers you're interested in gathering, the things that can fluctuate. In this case, saying yes or no. The sample represents the people that you gather for your study. It's always less than the population. The population would be everybody if you could theoretically go ask everyone how they're going to vote. The statistic is that number you're trying to calculate based on the sample. And the parameter is the number you're trying to calculate based on the population. And data is kind of a vague word, but data would mean like the numbers that you actually gather. In this case, people who said yes.